Hello everyone, welcome to the fifth day of this TezIndia Blockchain Bootcamp. Today we will be continuing in the project development. So some few announcements before the project development. I've been thinking that government project on the government only those who get the certificate and the goodies. Who completed the bootcamp get themes and ideas for the project will get from Moses We will also get an idea submission form, also feedback form, survey form. Everything will be available to you in WhatsApp. Also, there's a new group made for you all where you can get mentorship for your project. Remember, one you have to every submission before 30th of April on that platform. Everything is so easy. You can get a submit your project to GitHub. If you have deployed it anywhere else, you can Hello, Ojasvi. Am I audible?
Yeah, last time your voice was very uh, in bad quality.
Am I audible?
Yeah.
Okay. So, hello everyone. Welcome to the last day of this TezIndia Blockchain Bootcamp. Today we will be continuing on the project building topic. So, some few announcement before we begin. Regarding that project submission, you all have will get your goodies, certificates, cash prizes only if you submit a valid project on Tezos platform. That is one of the most important thing. For everyone else who have completed the bootcamp successfully, you will get your participation certificate. Your themes and ideas for projects, some suggestions, all will be provided by Ajasvi Rastogi. You will get that. A form will be circulated for within all of you for your idea submission, feedback, and all the survey. You will get all these survey links on your WhatsApp group. There's a group made, namely Tezos India and Code8, for your mentorship. If you register in the group, if you ask one-to-one mentorship will be provided to you from the Tezos team. You can ask your questions and everything that you have in your mind. Remember one thing: all the submission for these like projects, ideas, survey, everything you have to do before 30th of April. After that, your form will be closed. You can submit your project in form of GitHub. If you have deployed it somewhere, you can give the link. You can be you everything that is feasible to you. You can submit in that form. So that's all announcement. With this, we move to today's session. Today's the last session, and I hope you will all find it interesting. Thank you, and let's move ahead. Ojasvi, I would like you to take out the stage now.
Yeah. Just a second. Okay. So until now, we have learned to code smart contracts using SmartPy. We interacted with that smart contract using Better Call Dev. So now we need some method so that we can interact with that smart contract using our application. And the most popular way is to make some web content using React or something. And we have TypeScript and JavaScript libraries which makes it very easy to interact with them. So there are multiple libraries depending upon what kind of client application you want to build. Uh, Websites are the most popular ways to do it, but sometimes you create some app, maybe using Flutter or something. So there are a list of uh, libraries which I showed you guys yesterday. They are on this website, Tezos Developer Portal. You can go to tezos.com and go to Developer tab and Developer Portal. So here you can find all the resources, all the libraries, all the all the places from where you can learn things. Like these are the libraries, and we will be taking and we will be having some introduction to Taquito, and before that, I'll just clear one doubt that we got a day ago. Just a second. Hmm. Someone asked that is there uh, any source, some kind of templates for smart contracts? For example, we have opens up Blend smart contracts for Ethereum in Solidity. So for that, yeah, we do have that, and you can find them on the SmartPy IDE. Let me just open the IDE directly. Hmm. So when you open the ID for the first time, you get to see this dialog box, and here you can find the template. So you can click here or here, and there are tons of templates here. Well, there are some reference templates from where you can learn. Here are the some basic examples, like a minimal example to just get you started. So it will just show you a kind of a very boilerplate code for any smart contract of smart pi, or you can take a look at a lot of them, like time lock, on-chain views, right? And these are all um, kind of designed in such a way that it makes it easy for someone to understand them and learn from. So you can learn about lambdas in SmartPy. For example, let's say in this code we have some lambda functions like uh, flam private lambda, right? And this flam private lambda is being used in the entry point. So there's a uh, lambda, and in that we are calling self.lam. So these kind of smart contracts are very easy to read and learn. So this is a very great place to learn whatever concept you want to learn. And of course, there are hash function, etc., etc. But if you are talking about like complete template for some popular thing like tokens, right? So you can go to regular templates, and there we have some of the token for create some of the templates for creating tokens on Tezos blockchain. So we have um, F- FA 1.2 template. Okay, that's good for creating fungible assets, any kind of tokens which are generally known as ERC20 tokens in Ethereum. So FA 1.2 is very much similar to ERC20, just in SmartPy. You can read about. Um, I accidentally reloaded that. Hmm. So you can always check the template here, and it's well documented. Documented. You have tons of comments here to kind of teach you all the things that are being uh, that are happening inside this contract. So, and yeah, some things kind of overwhelm you because it's very new. So you always have some documentation for it, and I'll show you that also. It's it's on Agora. Let's go to Tezos Agora. Where is it? Yeah. So in Tezos Agora, there are uh, just, just a second. TezosAgora.org. Yeah, there it is. So we can go to tzip. Tzip is Tezos Improvement Protocol, and here you can find all the documentation for many things which keep on happening on Tezos. Okay, so there is documentation for FA 1.2 also. This one, and you can also, I think, get the link from here. Yeah, this is proposed here. TZIP 7. We'll open TZIP 7, and this is a complete documentation at how to use this smart contract. So if you are quite experienced with Ethereum development, ERC20 token development on Ethereum, then this will be very easy for you. You create token metadata and initialize this class, right? And at the end, all of these classes are inherited into a single class at the end. Yeah, yeah. This is a class which contains all of it. And one thing that I will also tell you, you actually need to read this code before using it. Because if you really want to understand how this template works, you need to at least read this code once. That's the best way to learn it, and that will make you understand all of the ins and outs of how to use it. Of course, you can refer to this improvement proposal, and it will tell you some of the stuff. So the best way to learn it is first read this documentation and then read the code, and that way you will learn it very easily. Similarly, there's another um, template which is FA2 template, and um, that's for both fungible and non-fungible assets. So you can read about it at TZIP12 proposal, and you can look at the code from here. And there's also a kind of a guide in SmartPy documentation that um, tries to teach you how to use this template. So you can always check that also. But the best way to learn it is again just by reading the code. This code is quite big, so it will take some time, probably a day or two, maybe more than that. But it's it's actually very uh, it's the best way to learn it, to be honest. So similarly, there are other templates like chain link oracles. If you are building a kind of oracles, there are some other simple examples like calculator, etc. Just to give you some reference at how to use them. We got a simple escrow contract, multi-sig contract, multi-sig with administrator functionalities, right? So game platforms and very small games like mini kitties is uh, similar to crypto kitties, chess game, tic tac toe. So these are the small smart contracts which you can use to read them and learn from them. And wherever you don't understand anything, for example, let's say I just randomly open mini kitties and I find something new. Can we find something new which we haven't seen yet? Hmm, nothing yet. Is there any multiplex? Yeah, set type. What is set type? So you can just copy that sp.set type and uh, search it in the docs. The search bar, just copy that, just paste that, and you'll get a complete documentation of what it is. So it's a function for setting a type of an expression. So you just specify the expression and a type for it. And type is something like sp.t record, and into the parentheses you have sp.tnet, sp.t string, and things like that. So there are a lot of examples also. So these are the snippets. We are setting the type of x as sp.t. We are setting the type of phi as sp.t string, like that. So yeah, this is the place where you need to go if you need some smart contracts. And you can always read about the documentation of the improvement protocol here. You can get its link from the same place from here, and that should be uh, enough. All right. So now let's let's take a look. How do we get the storage of a smart contract? I mean, obviously, we can always look at the storage of a smart contract using TZKT. It provides a very great interface. But when you are making some client application, for example, a web page, you need some uh, way to code it so that you can get the values from the storage and then show it in a very beautiful way on the website, right? So there are many ways to do it. I mean, EZKT also provides an API for that, so you can use that API to get the storage of any smart contract. Let's look at the API first. Okay, so there's a very brief documentation of how to use this API. So what I want is to get the storage of a contract. And my contract is this. It have a string and then a map, a mapping of string to nat. So let's look how do we do that. Is there any introduction? Okay. We can get from any kind of API. We are using Ethernet, so we'll be using this base URL, https://api.ethernet.tzkt.io. And then we don't need to get accounts. We need something from the contracts. Let's go to contracts. We can get contracts. We can get some more things from the contracts. Let's get the contract first. So this is used to return the list of the contract accounts. Contract number, contract code. Yeah, here it is. Get contract storage. So you just need to make request to this endpoint with address of the contract and then slash storage. So let's try it. Can we try it here? Okay, we can't. I'll open Postman for that. Let me just quickly copy the this URL to. Okay. So I'll create new collection. But let's create a new request. Before that, let's create a value. This endpoint. Okay. So let's create a new request and this will fetch the storage of a contract. And here first we need a base and then we'll make a request to that endpoint. That endpoint. That contract storage. Here it is. Boom, want to make a I can't. I just have to copy. So let's go here and let's also have the address of our contract in a variable. Contract is the address so that we can simply enter it here for all of the APIs. And let's make a request now. So just like that, very easily you can get the storage of any contract. Here we are getting the question, response easy, and the option. So this is directly fetching from the blockchain, from the smart contract that we have deployed on the Ithaka. And one thing that I'll tell you is this way you can't get all the values of a big map, because here options is a map. It's a map from string to nap, but you can't get the values of a big map like this way. Okay, so you have to use some other way. And why does that happen? Big maps are optimized in such a way that the way it's coded into the blockchain is to reduce the storage fees that we generally make while we do any kind of transaction. So big maps are generally used to store values when you're expecting a lot of data being stored in it. So if you think that there will be a lot of data stored in this big map, then instead of using map, you should use big map so that you can optimize uh, the usage of the smart contract. And that is why you use big map. And when you use big map, you cannot iterate on it, which means you cannot get the key and value pairs of that big map in one go. That's what we have done here. We just got all the key value pairs from this map in a single request. But you cannot do that with big maps because they are optimized in such a way that it's it's very it there's no functionality to get the values like that. So when you have some big map, you have to use some other API. I'll show you how a big map looks like. Don't have any smart contract as of now. Let's do one thing. Let's go to protocol and randomly search some smart contract. Let's go to Tezos domain. There are some smart contracts. Let's say if it has some big maps, storage. Yeah. So the metadata is something they are having in their contract state variable, and one of the variable is metadata, which is a big map. So when you have a big map, here you can see it's a big map from string to bytes. So big maps aren't stored in the contract storage. They are just having a reference to some other place in the blockchain. So it just have a big map number which is 1271. So this is the big map number 1271, and I can go to that separately. So now I'm on the mainnet slash big map slash 1271 slash keys, and this is it. So when you're getting the values of a big map, you need to make the API call to some other endpoint which is specially made for big maps only. So yeah, this is the so I can get the contracts big map from this API. I'll just copy this, create a new request, get this big map, the base, and as an address, let's find some other smart contract. Maybe current to that. Are we having any big map? No, we don't. Here. So this is the problem. They have some auctions map, I think. Yeah, it's a map, auctions map. And there are 929 items in it. So I think I'm assuming that this contract is holding the current auctions, and there are currently 929 active auctions in this smart contract. And sometimes the number of auctions can get very big. I mean, of course, 929 is also a very big number, but this is what you get when you can iterate on a very large value, very large map. So I'll just minimize that. And we got some big maps also. That's good. So we got some tokens, some token metadata. Token metadata, I'm guessing it would be very large, and that's big map number 860. Yeah, its size is quite big. So these are the values that this big map is holding, and it is continuously lazy loading that. These are the values this big map is having, and if you observe carefully, all the values aren't coming in just one go. It's coming kind of it's coming in batches, right? So I can click on any of the key in this big map, big map 860, which is having 80,000 keys. So yeah, that's a large value, and you can look at any of the value in this smart contract. So let's try to fetch this big map, 860 big map, using our API. So I'll get the big map of this this smart contract. This is the smart contract. I think it's the one. Okay. This is the smart contract. Can we get it? No. Okay, that's because it's on the mainnet. So I should use the mainnet um, base address. This is the mainnet. Hmm. So now I'm getting some big maps that this smart contract is having. What are these? So this is one big map who is having a key type of NAT to value type of some record, and its name is it's 861. That its number is 861, and I think its name is token. Yeah, this one's name is token metadata. Yeah, this is the one we were looking at, 860. Now we can make request to a big map to get the value of it. Let's try to do that. Create a duplicate, get big map value. So it's very easy to use API. This will be probably the last thing that I'll show so that you can get a clear understanding how to use this documentation and get whatever you want from the blockchain. Get big map keys. You can get the keys also, and I'm directly getting the value. Get contract big map. That's it. I and find the value there. You can definitely get the keys. You map ID slash key and then key. Quite easy. Return the specified big map key. Let's try to use this one also. I'll just type it big map slash its ID. What's ID 860 slash keys slash some key. And as a key, let's add 80224. Nope. Try to get all the keys. Key is a string, either key hash or plain value. Even if the key is complex, you can specify it as, for example, key address. So this should be a key. I might be doing something wrong. ID, that's an integer. And key, what's the key here? Token ID. Okay, so let's go back. Pick up the click on token metadata. It maps from NAT to token metadata value. So suppose I'm doing something correctly, I think key is 8024. Zero, two, four. Oh, it's no content. Don't know why. We'll probably get back here later. Maybe I'm missing something. So Yeah, the documentation is quite big. It will take some time to get a grasp of it, but you can always read all the documentation line by line, and that will give you a clear understanding. But my my preferred way to use is with Taquito. Taquito is a JavaScript slash TypeScript language. I'll go to the homepage, and it's always recommended to use this language because it will not only get you the storage of the smart contract, but also it will allow you to make transactions. So you can't make any transactions using this library. And there are other libraries also besides this one. There's a library of Better Call Dev also. But those libraries are generally a convenient way to fetch the data from the blockchain. If you want to make transactions, and making a transaction is kind of complex process. You need to specify what you want to do, and then you need to encode it in bytes, and then sign that using your private key. And the algorithm you need to sign depends on what algorithm you used to create those private keys. So by default, EDDSA algorithm is used to create your private keys, and your hash will start from TZ1. And then that you have to use the same algorithm to sign using the private key. You'll get a signed bytecode, and that you can inject into the blockchain by communicating to the node. Now, there are some things that I will tell you. The way you add something into the blockchain using some client is by communicating to the node. So there are multiple nodes, right? And you have to pick a public node. Sometimes you can host your own also, but for just development and testing purpose, you can use some public node. And then public nodes are open for us to make some request to those nodes so that you can uh, do some transaction, send some transaction to the node. And the protocol we use is RPC. So when you use this library makes it very convenient. You don't have to worry about any signing or anything, any algorithm or something. You just have to call some functions of this library, and that will allow you to make transactions. So I'll show you how we can use it. So we can go to quick start, and I'll just show you how to set it up. So um, I hope you guys know TypeScript. If you don't, then don't worry about it because it's very similar to JavaScript. It's working is quite similar to JavaScript. You just have to install that library in your project. Let's say you're making it with React, so you install it using npm install Taquito, or if you're using Yarn, you can Yarn add Taquito. And once you add Taquito, it will be good to go. So whatever uh, TypeScript file you are using, for example, this is the project that we are having. So here we have a folder called src where I'm keeping all the TypeScript uh, code. Currently, I'm having just one code, index.js, and I've initialized this TypeScript project using the command tsc under -fn init that will initiate your TypeScript project. And then you might need to configure some things in the tsconfig.jsm. For example, the things that I changed was when you can look at the project when we send the repository. Okay, and I've set the outer to /this, which means when I'll compile this TypeScript code to JavaScript, it will be um, saved in this folder. So this is a simple JavaScript TypeScript code which I wrote, and when I compiled it, it was compiled to JavaScript and it's here. So you don't have to write this one; it will be automatically done by the compiler. You just have to write this one. I'll explain how it works. So once you import Kakito, the first thing you need to do is obviously import the toolkit of it. So you can just import it using import toolkit from Kakito. Okay, pretty similar to JavaScript. And then you need to initialize a client variable through which we can do everything. So every public node have some RPC URL to which you need to communicate. You can get the list of all these RPC URL using this link. So this is tezostakito.io/talks/good start, and here you can click on this link and you can get all the list of RPC URLs you need. So there's a public RPC for mainnet, there's a public RPC for hands.net for Ithaka, another one for mainnet, hands.out Ithaka. So we are working with Ithaka. So this is the URL we need. So you just need to initialize the client with this URL. Let's copy this line and replace this string with your URL. That's what I've done here. Okay. And then I've just created a simple constant to keep track of um, our contract. And this is the same contract address which we deployed yesterday. Where is it? Yeah, this one. I just copied that address from here. It should be there. Now, whatever you want to do with the blockchain, you can do it using this variable, Tezos, which is just an object of Tezos toolkit with this connected to this RPC. And you can do literally anything you want from here. You can initialize some new account. You can import a faucet account. You can use it to connect with your hardware ledger. You can use this library to get your uh, transactions signed using some private key stored in an HSM on AWS KMS or Azure or somewhere. So, I mean, all of the blockchain stuff you want to do, you can use with Kakito on Tezos blockchain mostly. So let's try to do a very basic thing. The first thing I want to do is get the storage of this smart contract. So I'll try to store this. I'll try to get the storage of this smart contract, right? So how do we do that? So yeah, if you're using TestBridge, you can set up provider as a sign-up TestBridge. So yeah, this is something we should do first, I think. So I'll comment this for now. Also, so what we are trying to do, I'll get a balance of any address. So this is the code for it. Just copy it. This is Tezos in small letters, and it's nothing to actually capital. Keep it capital. So I can go to tezos.tz and then get balance is a function of tz, and in there you can pass any address. Let's input my address here. So in Ithaka, I have this I have this account which we created yesterday, which we imported from a faucet yesterday. I'll just paste it here. Instead of println, I will use console.log. And it's kind of quite easy to understand. This get balance will um, return a promise with balance, and that I can simply convert it to numbers. Initially, this balance will be big numbers, so I'll convert it to number using two number function, and then I'll divide it by 10 to the power 6 to convert it to Tez. So by default, it will send it in new Tez. So we need to convert it into Tez, and if there's any error we'll catch it. So let's call this a function. Okay, it's already been called. Let's try to compile it. TSP is used to compile, and when I compile it, the code will be updated in the test.js, and now I'll just run that code using Node. It will take some time because it's communicating with the RPC, but now you can look, the value is printed here in test. So I think it's the same value, right? Because I'm fetching from here, 91560. So this is a very simple way to get uh, the address of any account. Okay, and you can use in-memory signer also. It's generally useful when you are having some software keys. So instead of using any wallet or something, you can do it with in-memory signer, having your own software key. You can import any faucet account. So you just have this JSON as faucet key that we imported from the faucet website, and then you can simply call this import function. And now, yeah, let's do this thing also once. Let's try to transfer. So we have this much tokens in our faucet account here, and we want to transfer it. So we are doing some basic stuff here. We are just um, creating an amount called creating a constant called amount with value 2. So we are trying to send 2 tests, and we are creating address, and then we are transferring the amount to some address. So we use Tezos.contract and then .transfer, and then we need to give a map to a map as transfer param. So whatever you give here, there will be the transfer parameter, and the basic stuff we generally write in here is the to and amount key value pair. So the to is basically the address where you want to send the uh, token, and the amount is how much value do you need to send. And when you call this transfer function, it will inject this operation into the blockchain through RPC. Now RPC will kind of try to send this transaction to the mempool. It will be taken by some baker, and it will be minted into a block, and then the block will be added to the blockchain. So this is the whole process, and it takes time. So whatever is happening with your transaction, it's called an operation. You have injected an operation into the blockchain. And when you create an operation, you also get operation hash, which is to uniquely identify whatever is being done on the blockchain. So if I try to get the operations of my smart contract also, these are the operations. The first operation was to just create it, and then we added some options of yes and no, and then we voted on it. So these are the um, operations. And you can always get the operation hash. This is the operation hash. You can copy it from here. So whenever you create an operation, even if it's added into the blockchain or if it's in just a mempool, it will have a operation hash. So whenever you call the transfer function, you will get the operation hash from the promise, and then we are taking that and calling this function. So when we get the operation hash, we confirm it, and we don't confirm it, we just print that hash and we wait for it to confirm. So there is a function in this OP variable, OP class, which is confirmation. And when you call this confirmation function and pass a value in it, it will wait for some confirmation blocks. So let's say your operation is added into a block. That block is appended to the blockchain. But until when do you confirm that if it's valid or not? You need to wait for some time so that some more blocks are added to the blockchain, right? Just like we saw yesterday when we were originating our smart contract, we saw those 10 shields below the screen where they were kind of illuminating one by one in orange color, which will show which was giving us a feedback that how much blocks are added, how much confirmations we have. Confirmations are basically some uh, confirmation is like to get the idea that how many um, nodes have confirmed that. Right? So whenever you get one confirmation, it's like you should not have this value as one. You should have it like five, probably five or six something. But it's basically to set a threshold that how much confirmations are we waiting for. And here we are just waiting for one confirmation. So when this one confirmation will be observed, then we'll move next. We'll move to the next step, and then we'll get the hash of this transaction, and we can simply go to this website slash hash to look at it. So whatever operation you are doing, you will always get the hash. For example, if you look at this transaction, if we have operation hash for it, can we run it? Try to run it. So here we are transferring, and then this is the operation hash. You can do the same thing in your project. And it will take some time to try to do it here, but let's just try. We can quickly do it here. Hmm. Let's transfer it to my main account. Contact transfer, conversation, see if it's working. Probably I need to import some wallet or something. That will take time. Yeah, there's no sign up. I have to set up a sign up. Okay. Um, is there a fast way to do it? Let's let's create a software sign up. Okay, let's do that. So now what I'll do is I will get the private key of this account, which you should not do basically. You should use Beacon Wallet or something to integrate it with that. But I need to set a signer. Okay. So what's the error? I'll tell you the error. I was trying to make a transaction, but nowhere in the code I have specified that what private key do we need to use to sign it, and what uh, what method should we use to sign it. I haven't specified any of it. I just initialize this variable and now I'm directly making a transaction, which we should not do, right? So I need to set signer for it. Let's do that, and let's do that with a faucet only. I'll just create a new faucet account. Start on it. This is the key. Paste that here. Faucet equals. I just got the key here. Now I'll set the account which will be imported from this faucet, and that code is also given here. So we just need to call this function import key, and I'll probably need to use import key from here. There's a ticket to sign up, so I need to import that. Import key Tezos from Taquito sign. So I imported this import key, and then I'll use the function to import this faucet key into this Tezos toolkit. So that way, the account which we get from this faucet key will be used to sign the transaction when we are doing with this toolkit. So we just need to import it using this function, import key. And here you just need to give the toolkit first and the email, password, mnemonic. These are the mnemonic. And we are basically joining it with a simple space so that it becomes a whole sentence. And then the activation code. So hopefully when this code will run, um, this faucet key will be imported in this toolkit. And now we know that what private key do we need do we need to use while signing the transaction. Let's see if it works now. I'll compile it. And then run it. And now it's doing something. Okay, so the operation is sent. Let's try to quickly go and look at this operation. It's not like this. Probably it's not with the node of TZKT, so we'll just wait. So we are waiting for just one confirmation. Yeah, it's finally injected. And let's see if we can go to TZ stack and look at this operation. So this is a transaction and it was applied right at just this time. We sent to STZ from this faucet account to my main account. Let's check the balance of my main account now. Yeah, it's 2 more taps. So the transaction has been done successfully. Can you see the activity? Start from here. Let's take this and go to university. Yeah, now we can look at the operation. It's the same operation which was printed here. This one. We come here. So this is the transaction. We have just done the transaction using our code. Now, when you are dealing with the real project, when you have a front end with React or something, you won't be importing a new faucet key every time. So what you generally need to do is use a beacon wallet so that it can take open that dialog box which we saw, and it will give us multiple options to select a wallet, what kind of wallet do we need to use, and there the user can select Temple wallet and do the transaction. So there's a documentation for that also when you have a beacon wallet. Yeah, this is the thing. How to use a single instance of beacon wallet. So it's giving us all the snippets to use with Vue and everything. Wallet sign up. And yeah, you also have Ledger. Yeah, that we can do with code for now, but it will take some time to set it up. So you can always, if you have a hardware ledger, you can always look at the documentation. But mostly it's not needed. Mostly you just have, if you are building it with a web interface, you have a kind of a browser extension or something. So for now, yeah, faucet is enough to get you a clear understanding of how to do a transaction. Let's also try to get the storage of the contract, right? That's very important. Let's get that. And this was a transfer. I'll probably take it in some other function. Call as transfer. And in the main one now, let's call this storage. Storage. Hmm. Comment that. So when you need to get the storage of smart contract, you know, this come to look at the documentation and search for that. Loading the smart contract storage, single map, storage. Let's go to storage directly. No, maybe we should not go to storage directly. So this is how we can simply get the storage. Until now, this thing is already known to us, what we are doing here. But then there is a very simple way to get the storage of smart contract using this contract.storage function. So when you have a contract, we need to initialize the contract also. and we already know how to do that. Tezos contract, Tezos.contract, right? Um, so when we need an instance of contract into your code and we know the address of it, this is what we do. So we know the address, right? We have that address. This is the address. So let's try to do it again, right? We call that Tezos.contract at, and then we get the address of it. So now we have an instance of that contract, right? And now you can call the storage function to get the storage of this contract. So in storage variable, actually constant, you'll have the whole storage of this contract, but you won't be getting the big map value. For big map, you'll just get a reference to it, and then you need to go to separate sections to get the values from those big maps. So if I console log storage here and call the storage in the main, I should get the storage of this contract. And we don't need transfer function for now. It's just there to take a reference. So let's compile that and run our JavaScript file. Yeah. So here we got the storage of it. It's a simple object with question is marked by easy and options, which is a Michelson map, right? We see Michelson because under the hood, your smart contract is converted into Michelson only. That's why we see Michelson map. And in this map, we get a schema so that we can know what are the keys, what are the data types of keys and values. Okay, so this is the key schema, which basically means what kind of key is it. So it's a string and value is a nat, and the key map is a simple mapping, right? And the value map is the no is a big number. This big number's value will be 1, I think. Let's say what is the value? Storage. Yeah, it's 0, and the value of this big number will be will be 1. This is how you can simply get the storage using Taquito. It's quite, I think it's easier than calling the API again and again, and it also uh, makes it quite maybe centralized or something because you're making the request to the servers of TezKT, their public server. That can clog them also. It's better to use your own um, library and directly communicate with the RPCs. So yeah, this is how you can get storage. And at last, let's also look at how to call the functions of a smart contract. That's the most important thing, right? So let's try to call an entry point function, which is both of the smart contract. So let's go to the documentation and look how do we do that. Smart contract interaction. The first thing we need is to load that contract, right? So we already know how to do that using the add thing, right? Where is it? This. We got the contract like this. And then we need to get some parameters. So let's look at the code, what is being done here. So we got the contract as C, then it's doing something. We can inspect the contract method and data type using this thing. So they are trying to look at the contract method and its data type using this function that we don't want. We simply want to uh, make a transaction by calling a function. So they are doing this here. So they got the contract from this add uh, function, and then they are calling the entry point function of that contract using this line. So you simply have contract.methods that will give you all of the methods, and one of the method in this smart contract is called increment. So they just call increment and then input the value. It's that simple. So they kind of created an instance of the function being called, but they still haven't sent it. So we just send it using the send function. Let's try to do the same thing here, and let's create a separate function for that, const vote, and so this vote will have a string parameter, which is the option. Oh, I just wrote the wrong syntax. So we'll get an option here, which will be the yes or no, and then we insert the contract. Um, Using this line so that we get the contract of it, right? The contract at this address. So now we have the instance of the contract, and now we'll send this transaction. So it will be an operation hash which we will be getting. Let's call it off hash, and that will be await contract dot methods. Yeah, this is it. So we are getting the method. We are calling the vote function. We are sending the option, and then send it. That will give us the off hash. We can console log that. Okay. And then let's have a, okay, there is no hash. No problem. And then we need to wait. Yeah, we need to wait while it's confirmed. So this is a function for it. Have a confirmation equals wait of hash dot confirmation one, which will wait for one confirmation. And once it's confirmed, and console log, this will be printed above, waiting for it to be confirmed. And once it's confirmed, we can simply just print the maybe URL of it. So I'll use it as an equivalent. Go to the operation. And the same console log here. Don't need this. This is our hash. And the prefix is this. Okay, so this should be enough to make a transaction which will vote something in this smart contract using the account that we imported using this faucet key. Okay, and I think in return we can simply return the confirmation. So let's try to vote. Yes, let's see what happens. First we compile it and then we execute. Okay, so the transaction has been made and injected. This is the operation of it. So the operation is injected. Yeah, I did something wrong here. It should be operation dot or hash dot hash. No worries. The operation should be done. Let's go to the contract, and yeah, we see a new operation which is done 33 seconds ago, and now the storage should be updated. So we got 2 years. Earlier it was 1, now it's 2. Similarly, we can vote no also. This time the operation hash should be correct, I think. Compile, execute. So you should be getting a pretty clear understanding of how to do a transaction using Taquito. Very easy, just calling a bunch of function. I think it's even easier than using a backend, because in backend you need to make uh, HTTP calls, right? And as an input, you need to give some form data or some JSON data, a bunch of different things, right? But here you just simply call a function as if it's already existing into your local code. So the operation is injected. Yeah, now I clearly see the URL to photos. There's another operation now. If I refresh it, I'll get it. Yeah, 28 seconds ago, this operation was done where I sent no as a parameter. So yeah, this should be enough to give you a clear understanding of how we use Taquito to make transactions, to fetch data from blockchain, even if it's the balance of the address, or if you want to get some storage from the smart contract. You can use any one of the methods to get the storage from the smart contract. It's kind of difficult to get the values from big maps using Taquito, but it's it's good to use Taquito only, because it will, because that way your project will not depend on TZK API. Similarly, you can use the better called that Dev API also. You can go to the documentation through this website. Here it is, API. You again have all the docs, getting the values, getting the big map, uh, getting contract, storage and all. So it's kind of a similar thing. So yeah, that's it. That's the front end part. That's how you integrate with it. And you can always use this code in whatever application you are trying to make, even if it's React or Vue or Angular. All of them uses JavaScript. So you can always just type your TypeScript code in the SRC and then compile it, and then use this index.js in your projects. can import it anywhere you want. So that was the integration part. If you have any questions, I'll start taking it. Okay. I have watched first two lectures. After going through all five, I will do the project. Yeah, good idea. Are you looking forward to it? Okay. So I don't see any questions. If there are any questions, you can type it in the chat. Hi, your tutorial was inspiring, but the audio quality is very bad. Can you please use a headset in future? I'll use not just a headset. I'll completely buy a new microphone. I know about the quality of the audio. Thanks for the feedback. I'll buy a new mic probably uh, in the future, and maybe a camera. I don't know. I'm waiting for the questions. Meanwhile, I can give you some of the ideas that you can use to create your project. Um, some of the problem statement that you can have, right? You can make on any of the theme, whatever theme you want. There's no restriction in the theme, and you can make any kind of any project you want, and it would be great uh, if it's actually quite mm, quite quite unique with some their concept or maybe. But still, I can give you some of the basic ideas that I currently have. So you can make a kind of a crowdfunding platform maybe. So in that you have a you have basically two types of users. The first one are the people who want some funds. Okay, so you will have a smart contract and you will send uh, you'll make a function where people can raise a request for funding, and then other people will be able to call some other function which we have created, and through that function they can send the amount into the smart contract. So that amount will be stored into the smart contract, and then the request will be having some threshold of some number that we at least want this much amount of money, and when that much amount is fulfilled in the balance of the smart contract, the requester can call another function to withdraw that money. Now, this will have some functions like how many functions? One function to raise a request, one function to donate, uh, one function to withdraw. Yeah, there are three functions, but you also need to check some things. The first thing is when you're calling the donation function, the second one, you have to make sure that the parameter that the person is sending into that function is equal to the amount he's sending. So you have to record how much amount a person is sending into the smart contract. Otherwise, you won't be able to keep a record at how much a person has sent, because you need that, because you also need to give an option for the people to take their money back. So let's say if I am a donor and I donate, let's say 40 Tez into the smart contract for some uh, for the for anything which for which the request was raised, and later I realized that okay, I don't need to donate and I'm withdrawing my 40 Tez. So in that case, you need to make a function that can be used to withdraw the amount. And when you are donating, you need to store how much a person have donated. So probably you will do it in a map with addresses as the key and values as the amount in neuters or something. And when someone is calling the withdraw function, you have to verify that that person exists in the donor map, and if he or she is withdrawing the same amount which they have donated. And you also need to verify in the withdraw function, not in the withdraw, but in the claiming function where the requester is finally claiming all of the funds for his request. You need to check if the net balance of the smart contract is greater than or equals to the minimum value that he has specified in the request. Yeah, and you can also put some flag variables maybe to kind of uh, store whether your contract is whether that request is active or not, whether it's already claimed, right? So that sort of stuff. So it will probably have 4 functions in total. That's one idea. Another idea is a naming service. So in naming service, it's like a it's like you are creating your own names instead of your wallet address. So what you need to do is you will make a smart contract um, in which it will be having some a map of address by a string, and it will hold the registries of whatever names you have bought. So as a user, what you will do is you will send some amount into that smart contract, let's say $10, 10 Tez, and those 10 Tez will be holded into the smart contract. And in return, it will generate some string against your address. So let's say if I'm a user and I want my address to be named Ojasvi, so um, I'll call a function in it that will be called probably registered. So I'll call register function and pass my string, which is Ojasvi, and I send some amount, and that amount needs to be verified that if it's the same amount which is actually needed. Let's say that's 10 tests. So I send 10 tests along with the parameter of Ojasvi, and that way the smart contract will store my name along with the registry. So now the map will store my address and the value of the string which I sent. So that's kind of that's a handy way to just you know send your friends your just name, and they can always look up in the smart contract to get your address. So it's a convenient way to use to kind of identify different people by their name instead of uh, some address. And the owner of the name will also have the permission to transfer it to some other address. So let's say I have some address A, and I'm switching to some other address as my main wallet. So I need to transfer that name to some other wallet. So how do we do that? I'll create a new function, and in that function, I need to specify um, just an address. And that function will first of all verify that the caller the sp.source is equal to, yeah, also it will also have a parameter of the name, right? So then it will verify if the name, the value against that name, which is the address which is stored in the registry, is equal to sp.source, which is the person who is calling that function. And if both of them are equal, which means it's actually the owner of that name. And then I'll also pass a parameter of to which uh, wallet address do I need to send it. So that function will simply replace the value of my previous address with the new address. And that way, I have kind of transferred that name to some other wallet, right? So that's one permission a owner will be having. And also you can create a new function for deleting that also. So let's say I'm done with the name that I had, and I probably want some new name or something, but I want to delete my name from the registry. So I can simply call the delete function, which will be in the smart contract, and then pass the string. That what string do I need to delete? It will first verify if I am the owner or not, just like the previous thing. And if I am the owner, it will simply remove that key value pair from the map. Quite simple. And for all of these projects, you'll be making your own front end, whatever way you want, whatever framework you want to use, maybe React or Angular, Vue, or maybe plain HTML, CSS, JavaScript, whatever you want. And um, from there, you can create a complete user interface to show the storages that, okay, I am this person, I'm connecting a wallet, and when I connect a wallet, it will show my name by fetching it from the smart contract. And then I'll have the options to transfer and everything. So if I click on transfer, it will ask from me the parameters, a parameter of what name do you want to transfer and to whom you want to transfer it, to what wallet address. And then I click on transfer button, so it will transfer the name to that wallet. And then besides connecting wallet, I will also have an option to disconnect, so that I can disconnect my wallet and then connect it from the new wallet. And when I connect it from the new wallet, I'll get um, the name in that wallet. And I'll also get an option to delete, right? So these are the things which you can create it in your own front end and use your own styling or whatever you want. And you all already know how to interact with the smart contract using Taquito. So that won't be a problem. Similarly, you can create your own user interface for the crowdfunding website also. It will be done in the similar ways. It will show me the list of the requests and maybe the value of the balance of the smart contract, and it will also show me the options to donate into a request. So you need to design your own schema. It's a kind of a complex project to design the schema, that what are the types of record you'll be making. But you have any previous experience of general web development uh, in using some, basic uh, frameworks like the databases like SQL database or MongoDB, etc. You know how to make these kind of schemas and what values you need to store. So it's very similar in the smart contract also. You just need to create a bunch of maps with records and everything, and you can use the same process in the smart contract. Another idea is just create your own token. So we already saw the FA 1.2 uh, template to create fungible assets. So you can create your own token, a simple ERC20 kind of ERC20 like token, uh, with some with some total supply, right? And it will be within probably someone's wallet. It will have its own transfer function. It will have its own burn function, and all of that is specified in the FA 1.2 template. So if you are trying to, if you will learn that template, it will be very easy for you to make your own fungible asset. So you can do that also. Or if you are quite experienced with NFTs and everything, then you can use FA2 also. However, it's a relatively big or smart contract, so it will take some more time to learn. And of course, you can create your own voting system also. But the one that I made is a very minimal voting system, which just have a single question in a smart contract, right? But a complete voting system or kind of a more functional voting system is, first of all, there will be a set of admins. Here, there is no admin. Here, the person who is just deploying the smart contract have uh, the option to specify the question, nothing else. So we can generalize it. We can create a list of admins, and the admins will be having the option to create new questions, right? And the options of those questions, but other people, the general people, won't be having any option to create new options or create new questions. Only admins can. But then they can always vote for those options. So that's one thing they can do. Um, you can also optionally check that if a person is not voting twice by storing each of the person who is voting for a option. And you can also make it like if a person wants to be an admin, they can raise a request to become admin. That will be a separate request. And then it will be a kind of poll only. So a person raises a request to be admin, and the other admins will be voting yes or no for that person, that whether he should become the admin or not. And if majority of the people vote yes, then that person will be added into the admin list and the poll will be ended. And the admins will also have some option to resign from the admin list also. So these are the functions that will be required in this project. You have a list of admins. So the first function will be to create questions. It will verify if the sender exists in the array list of uh, admin, and then there will be a function to create the options for the question. So it will take two parameters. The first parameter will be the question, and the second parameter will be the option, and that option will be added into that question. And then there will be a function to vote, so anyone can vote on um, the poll. Then there will be a function for raising a request to be the admin. That will be a separate function. And in that function, a new voting list will be created. And in that list, there will be a separate question that whether this person should become the admin or not. And on that poll, only the admins can vote. So there will be a function to vote for admin, right? And in that function, you first need to verify if the caller is an admin or not. So if it exists in the admin set or not. And if it does, then it will probably increment the value of yes or no. And it will also check if the number of votes are done by all the admins. And if it is, then it will take the decision, right? If 50% or more have voted yes, then it will be added to the admin list. Or if it's no, then nothing will happen and the poll information will be erased from the smart contract just to save space, right? Mm, and yeah, at last there will be a function to resign from this admin. So these are the projects which you can make. It can be a big project if you are a beginner, and it can be a small project if you have experience with blockchain development in general. But still, it will be very fun to make any of these. Or you can think of your own idea, of course, which will be somewhat uh, on a similar level to these ideas. And also don't forget to make some kind of front end to integrate with it, right? So that it's very easy to integrate. I mean, obviously you can always go to better call, but that's for developers. If you're making some application for general public, you need to make some good UI first, right? So these are the ideas. If you have any questions, feel free to ask here. I'll wait for some time. The team member can be from outside or only people who are in the boot camp. I'm not sure about it. If anyone else is, we can answer. Okay, you have sent it in the group also. You'll probably get the reply to this question in the group soon. If there are any other questions related to any of the concepts which are shown today, you can ask. There are no questions. We can probably move to the quiz part. Right.
Okay, as we have covered everything for today's session, Ojasvi, is there anything you want to cover up before we move to the quiz?
Um, Not exactly. There's just one question which is in the chat. I'll just cover that. Do you have any idea about the Tezos India Fellowship? No. Uh, I'm also waiting for that, but I don't have the idea currently. Yeah, we can move to the quiz.
Ojasvi, is there anything you want to cover up before we start moving to the quiz?
No.
Okay,
Yeah, things
let's
are done.
start with the quiz. I'll just share my screen. Just wait. Okay, Ojasvi, you can turn off your sharing so that I can share. So I guess my screen would be visible. Also, I'll drop the link in the chat. Can you just share in the YouTube stream?
Yeah, just a second.
Sure.
Shared it.
Everyone join fast so that we can start with the quiz. We will start the quiz at around 9:30. So just a reminder regarding the project submission. Regarding the certificate, goodies, and the cash prize, you will get those only and only if you have submitted a valid project. By valid project, I mean that your project should be a copy paste. It should be a there should be no plagiarism in the project. And second thing is that your project should be based on Tezos platform only. You shouldn't build it on any other blockchain technology such as Ethereum or anything else. Third is that if you haven't if you are not if you're not doing the project but you have completed the boot camp, then you will get the participation certificate from our side. There's no issue in that. And next is the themes and ideas. I guess Ojasvi would have already shared the themes and ideas for your project. You can go beyond that also. There is no such restriction that you have to do in that only. Okay, next is that there will be some forms circulating within you in the groups. There would be one form for your submission of idea. One would be there for feedback. Please make sure to submit the feedback so that we can get to know that how we can improve. And there would be another forms of survey. There will be some survey regarding any questions. Please fill that. It will be good for us. And another thing is mentorship. There is a particular dedicated group for mentorship. Ask your doubts there. You will get personal one-to-one mentorship from Tezos side. You can get help from there for your project or anywhere ahead in your next is your submission. Okay, so you have to submit anything, your project, your ideas, anything before 30th of April. There will be a Google form. You can upload your project to GitHub and then share a link, or you can deploy it somewhere on Netlify and then share us the link. Or in the worst case, if you haven't deployed it anywhere, you have just stored in your local system, just upload the zip file. We have no problem. Anything you are feasible in, just share in that form. And that's all for now. These are all the announcements that I had to make. And now we will just proceed to the quiz. Still, I will wait for some time. It's 9:26. We'll wait for some time and then we'll start. Since so many participants are joining now, we will just wait for some time, like around 9:35, and then we will start the quiz. So no one is right now joining. So we will just start the quiz. All the best to everyone. Try to ace the board today. We will see you after the quiz. Let's start the quiz now. So I guess most of the participants have completed the quiz. We would end the quiz now, then see the result. So congratulations to Shubh Jain for acing today's leaderboard, followed by Manjunath and Siddharth Das, I guess. Then all the top tens are Shishank, Piyush Bedi, Mayank Panda, Subhanshu, Ayush, Kevin Jaramillo, and Aditya Rane. Congratulations to all of them. And one more reminder that please submit your project, a valid project, like on Tezos platform. It is very easy for you to, like we have seen it in the boot camp. It is very easy to build on Tezos platform. And all the best everyone for your project. We will all be very interested to see your projects. Thank you everyone.